The first great breach in the October War was not made by a tank gun. It was made by water. On the afternoon of the 6th of October 1973, while Egyptian infantry crossed the Suez Canal in assault boats and Israeli strongpoints shook under artillery fire, teams of engineers dragged hoses, pumps, and pipes toward one of the strangest obstacles on any modern battlefield, a wall of sand rising from the canal's eastern bank. It had been built to slow an army at the exact moment when delay could be fatal. Yet the Egyptian answer was not a heroic charge or some secret weapon from a factory floor. It was a practical idea, rehearsed again and again, that turned the canal itself into a tool for breaking open Sinai. If you would like to move beyond the podcast, you can see my available books at militaryauthor.me. And at trackpads.com, you will find magazines and galleries with hundreds of thousands of photos and videos to explore. To understand why that mattered, picture the crossing from the Egyptian side without a map. The soldiers begin on the west bank, facing east across the water towards Sinai. Beyond the canal, the ground does not simply open into desert. It rises sharply in a man-made embankment of sand, a steep barrier meant to trap attackers after the dangerous boat ride, but before they could bring heavy equipment ashore. Infantry might climb it with ladders and ropes, but tanks, trucks, artillery, and bridging vehicles could not. An army that could put men across, but not vehicles, would have only a fragile foothold. Those men would be exposed to counterattack, cut off from support, and forced to fight with whatever they could carry on their backs. The sand wall was therefore not just dirt piled high. It was a race against time, shaped into an obstacle. The Israeli logic behind the rampart was straightforward. If Egypt crossed the canal, the first assault waves would have to struggle up the eastern bank under fire, while Israeli defenders reported the attack and armored reserves moved toward the front. Every minute spent stuck at the wall was a minute for Israeli tanks to arrive. The barrier supported the broader purpose of the Bar-Lev line, not to be an unbroken fortress, but to delay, warn, and hold long enough for mobile forces to strike. In theory, this made sense. A canal is already a difficult obstacle, and adding a steep sandbank to the far side made the crossing even harder. But every obstacle has a hidden weakness. If the attacker has studied it closely, trained for it patiently, and found a way to open it quickly, the obstacle can become a trap for the defender's imagination. At first, Egyptian engineers considered methods that sounded more dramatic than the one they finally used. Explosives could cut gaps, but blasting sand is not like blowing open a steel gate. Sand absorbs force, collapses irregularly, and can require enormous quantities of material to move. Mechanical equipment could dig, but bulldozers and heavy machines would need to reach the far bank first, which was exactly the problem the army had to solve. The challenge was almost absurd in its simplicity. How do you move a mountain of loose sand quickly while under fire before your bridgeheads are strangled? The answer came from thinking less like a tank commander and more like a civil engineer. Sand could be dug, blown apart, or shoveled, but it could also be washed away. The proposal most associated with this solution came from Baki Zaki Youssef, an Egyptian engineer officer who had worked with water-moving methods in civilian construction before applying the idea to the canal problem. Rather than attack the rampart with explosives alone, engineers could use high-pressure pumps to draw water from the canal and blast the sand into slurry. The idea was elegant because it used what the battlefield already provided. The canal, which Israel counted on as a barrier, became the Egyptian engineers' reservoir. Water under pressure could bite into the rampart, carve channels, and pull sand downward in streams until a passable opening appeared. It was not glamorous, and it did not look like the popular image of armored war. That was precisely why it was so important. The method still demanded courage and organization, because a clever idea is useless if it cannot be executed in the middle of battle. Pumps had to be moved into position, hoses connected, crews protected, and work begun while the crossing was still under fire and confusion. The engineers could not wait for perfect safety, because safety would come only after the breaches were open and the bridgeheads strengthened. They worked close to the water, near the very places Israeli artillery and small arms fire might be directed. Around them, infantry pushed inland, anti-tank teams prepared for Israeli armor, and commanders tried to keep the sequence moving. One broken pump, one missing hose, one jammed approach, One delayed crew could slow the movement of tanks and vehicles behind them. The crossing depended on unromantic competence under extreme pressure. This is where Operation Badr becomes more than a surprise attack. It becomes a lesson in preparation. Egyptian engineers had practiced the work repeatedly before the war, learning how long it took to open lanes, how many pumps were needed, how crews should move, and how the sequence connected to the arrival of bridges and ferries. Training turned a risky improvisation into a battlefield routine, though no routine feels ordinary when shells are falling nearby. The point was not simply to get a few men across the canal. The point was to transform the East Bank fast enough that an army could follow. Once gaps were opened in the sand wall, the crossing could begin to change character. What had started as infantry and boats could become a bridgehead, reinforced by tanks, guns, trucks, and supplies. The sand wall also reveals why engineers are so often decisive in armored warfare, even when they appear in the background of the story. Tanks are powerful machines, but they are helpless before certain problems unless engineers solve them first. A tank cannot swim across the Suez Canal on its own. It cannot climb a steep sand rampart because a map says the attack must continue. It cannot exploit a breakthrough through a blocked route, a destroyed bridge, or a minefield unless somebody clears the way. The glamorous moment, the armored advance, depends on the hidden labor that makes movement possible. In that sense, the Egyptian engineers on the 6th of October belong to the same long tradition as the bridge builders, mine clearers, road makers, and recovery crews who have always stood behind successful mechanized operations. The work at the wall unfolded alongside the crossing of heavier equipment. Ferries and assault bridging systems had to be brought forward in a carefully managed flow because congestion at the water's edge could become deadly. Tanks waiting to cross needed routes, and routes required breaches. Trucks carrying ammunition, fuel, medical supplies, and communications equipment needed the same openings. If the East Bank became clogged with men but no vehicles, Egyptian success would remain vulnerable. If bridges went in before the far side was ready, they could be damaged, blocked, or wasted. The crossing, therefore, moved like a chain in which every link mattered. Infantry created the first space. Engineers widened it. Anti-tank teams defended it. Air defenses guarded the sky. Armor and logistics then turned the foothold into a position that could endure. For Israeli defenders, the speed of the breaches was a shock. The sand rampart had been counted on as part of the clock that would favor Israel. It was supposed to help buy time for armored reserves to gather, move westward, and strike the attackers before they were secure. But Egyptian water jets cut through that assumption. As more openings appeared, the canal line became harder to restore by a simple counterattack. Israeli strongpoints could be isolated, bypassed, or overwhelmed while Egyptian forces expanded around them. The battlefield no longer resembled a failed raid that could be crushed at the water's edge. It was becoming a series of bridgeheads, each connected to a growing system of troops, weapons, and supply. The sand wall had not vanished everywhere, but its purpose had been broken where it mattered. The psychological effect was almost as important as the physical one. The Bar-Lev defenses had carried a reputation larger than their actual design, and the sand wall was part of that reputation. To see Egyptian soldiers cross the canal was alarming enough. To see engineers rapidly opening lanes through the rampart meant that the attack had been planned in a depth Israel had not fully appreciated. This was not the defeated Egyptian army of 1967 stumbling forward into disaster. It was an army executing a method built around specific Israeli strengths and specific Israeli expectations. The wall had been made to delay Egypt until Israeli speed could decide the battle. Instead, Egyptian preparation delayed Israel's recovery. Modern war often turns on that reversal. The side that controls time controls the meaning of firepower. None of this made the operation easy or bloodless. Engineers working at the canal were part of a battle in which men were killed, wounded, burned, drowned, and buried by collapsing sand or shell fire. The success of the method should not hide the human cost of carrying it out, nor should it turn the engineers into characters in a clean story of cleverness defeating brute force. They operated in a world of noise, fear, orders, dust, smoke, and uncertainty. Some crews did their work under better cover than others. Some lanes opened faster than expected, while other tasks in the wider crossing faced delays and friction. Real military success is rarely smooth. It is the ability to keep enough of the plan working while the battlefield tries to tear the plan apart. The breaches through the sand wall helped make the first Egyptian success irreversible in the short term. Once tanks and heavier weapons began crossing in meaningful numbers, the bridgeheads became far more dangerous to attack. Israeli armor could no longer assume it was racing toward a thin line of infantry clinging to the bank. It was moving toward prepared positions, anti-tank teams, artillery-backed defenses, and an enemy whose vehicles were now entering Sinai behind the assault waves. The crossing had passed from daring to structure. A bridgehead is not just ground held on the enemy side of water. It is a promise that more force can arrive. By opening the sand wall, the engineers turned that promise into a road, and roads are the bloodstream of armored battle. Blasting the sand wall deserves an episode of its own because it changes how the whole campaign should be seen. The October War did not begin as a simple clash between Israeli tanks and Egyptian tanks. Its opening success rested on a chain of practical answers to practical problems, and the most important of those problems was how to move an army across a canal and up onto the far bank before the defender could react. Egypt's solution was disciplined, physical, and brilliantly suited to the battlefield. Water cut the sand opened into lanes, the lanes received bridges, and the bridges carried the weight of a war that suddenly no longer belonged to the assumptions of 1967. In the history of armored warfare, this is the quiet lesson beneath the thunder. Before armor can maneuver, someone must first make the ground possible.
You've been listening to Famous Tank Battles. These battles were never just about machines. They were about doctrine, terrain, firepower, logistics, and the hard problem of turning shock into victory. For more military history writing and books, visit militaryauthor.me. And for magazines, podcasts, and a massive archive of military photos and video, visit trackpads.com. Thanks for listening.